Okay, so let's try to study this problem target sum. So the problem is given nums and target. Okay, so how many different ways we can build the target? How many different ways we can build the target by adding plus or minus one before each number? So you can see over here. So we have added minus one, plus one, plus one, plus one, and the target has been given as 3. So to reach target we can take 5 ways. Okay, so 5 ways we can take to reach the target. Okay, and the constant has been mentioned as less than is equal to the length of the nums array can be maximum 20. Okay, and very important to note, the target needs can be negative as well. So target is less greater than is equal to minus 100,000 and less than is equal to 1000. Okay, so we can see there are keywords over here. So we can see like there are different ways. Okay, different ways we how many different ways, so very important. Okay, so how many different ways you can build the target. So so if how many different ways or possibilities we need to find. So this keyword, what if we found, then we can take recursion. Okay, okay, the next thing is the target is fixed. So target is fixed and we need to find different ways or possibilities. Okay, then if the target is fixed or there is a constraint, so then we are bound to take this target, so we cannot exceed this target. Then which algorithm comes to our mind? So we can think of taking knapsack. Okay, so one thing to note over here, so either we can take plus or we can take minus, and we need to reach a target. So this is choice 1 and this is choice 2. Okay, we can say, so we can make 2 choices and we can reach target. So that how many ways that we can find, we need to find out. So we can think of taking a recursive function with index and current target, like before, like we used to we already done in knapsack. Okay, so over here we can say so, and this DFS function we can call with 0 and the current target, so which is the target over here. Okay, so DFS of 0, and over here what we can do, we can return choice 1 plus choice 2, right? But what will be the choice and choice 1 and choice 2? So over here, rather than writing this, so we can say return DFS of index plus 1 current target. Okay, so we are taking the choice 1. Okay, current target plus, we are taking plus nums of index. Okay, and another one would be DFS of choice 2 would be DFS of index plus 1 comma current target minus nums of index. Okay, so this is choice 1 and this is choice 2. If we add, as you need to find the number of ways, so we can add 2 choices. Okay, okay, and then what we can write the base case over here. So if index is equal to length of nums, so we can return 1 if the current target is equal to 0, else 0, right? Now with this approach, what will be the time complexity? So we are making, at certain point we are making 2 choices, so time complexity would be 2 to the power n. Okay, and space complexity we are using auxiliary stack space, so it will be O of n. Okay, now if we like before, if we try to draw the recursion tree, we'll see that there are overlapping subproblems. Okay, and again, like when the overlapping subproblems exist in a solution, then we can optimize with dynamic programming. Okay, so first approach we can think of taking memoization, and the second after that we can think of taking tabulation over here. Okay, but I'll not write the code over here, so I'll try to write the code in our coding section actually. Okay, so next, so this is one approach. Okay, this is one approach. Okay, let's try to think about approach 2. So this is approach 1, I can say, and this is approach 2. Okay, so we can see, like, let's take this as an example. Okay, so this one, so +1 -1 +1 +1, 4 times 1 plus 1, right? So 4 times +1 and -1. Okay, and we need to reach target is 3, and this is giving us 3. Okay, so over here we can see this part, and this part. Okay, so we can say like +1 we can take together. Okay, so +1 +1 +1. Okay, so 4 times +1, and -1 we can take in the one side. Okay, so this also gives us 3. Okay, now we can say like we can take this sum of these subsets we can take as S1, and sum of this subset we can take S2. So S1 minus S2 is equal to 3, which is, we can say, we need to find the target. Okay, now we can write this S1 minus S2. Now we can say like S1 plus S2 is equal to total sum. So if we sum up two sums, right, we can make the total sum. So which is the, if we add all these numbers, then whatever sum we'll get, so then that will be, so S1 plus S2 will be equal to that. Okay, so we can say like, then we can say like if we sum up these two equations, so then we can say like 2 into S1 is equal to target plus total sum. We can write that. So S1 becomes target plus total sum by 2, right? So now this problem becomes count number of subsets having target as target plus total sum by 2. Okay, so again we need to reach the target. So this target is fixed, so target plus total sum by 2. So then we can go with knapsack. Okay, and this count of number of subsets, so we can take recursion, same include exclude case, like we have done before. Okay.